Good afternoon. My name is Oscar Villarreal, and I will be telling you a little bit about the project that I've been working on over the summer and I'm currently working on. Investigated the mechanisms of CXCL12 log dimer in combination with radiotherapy for head and neck cancer. A little bit of a background. Head and neck cancer unfortunately exceeds 6,000 cases per year in the United States. Surgery, radiation therapy, as well as chemotherapy are central to its treatment. Unfortunately, the 5-year survival remains under 50% using current approaches. Now, this being said, there's an urge to identify novel agents that can synergize with these current approaches so we can really combat and head and neck cancer and have a better prognosis for the people that are affected by it. Now, we have recently identified synergistic effects between CXCL12 and its dimerized form with radiation therapy. CXCL12 works with VI's receptor CXCR4, and interestingly, this CXCR4 CXCL12 axis has actually been shown to be very prevalent in malignancy. CXCR4 CXCL12 signaling axis has been implicated in angiogenesis, metastasis, proliferation, and invasion. Now, this is in regular human cancer physiology, but investigators, partly from MCW, have actually seen that by inducing CXCL12 exogenously into the system, you actually see the reverse of these effects. And the hypothesis behind this is that CXCR4 and CXCL12 works via a partial agonist and partial antagonist mechanism. And by giving the system a high enough concentration of CXCL12, you can actually reverse those effects that are normally seen in cancer physiology. So now a preliminary study was done in our laboratory using a humanized mouse model of CXCR4 expressing head and neck cancer mice using the FADU cell line. And we actually identified a synergistic tumor effect combining the log dimer CXCL12 with tumor-directed radiation therapy. You can see that in this image. Basically, we injected the mice with these cancer cell lines, let the tumor grow and establish and grow. And then we had our 4 groups. And at around 30 days, we measure the tumor size, and we see that here, the log dimer plus radiation therapy has a significantly lower tumor size than any other of the groups. So this is telling us that whatever is happening, it has an anti-proliferative and anti-tumor effects that has been synergistic with radiation therapy. Now, in vitro, we see similar effects by measuring the amount of cell death via this Nexin V staining. Here, no radiation, log dimer CXCL12, we see a massive increase in cell death comparing AMD 3100, which is a CXCR4 agonist, full agonist, the log monomer version of CXCL12, and our control. Now we see that there's an even higher increase in cell death when given a grade of radiation therapy. So now this is telling us that whatever's happening is killing tumor cells and restricting the growth of the tumor. So now our hypothesis is that log dimer CXCL12 works as an anti-proliferative and anti-apoptotic agent through a partial agonism of the CXCR4 receptor in head and neck cancer. And basically the purpose of this project is to really investigate the mechanisms by which CXCL12 log dimer is killing those cancer cells. So the materials and methods, basically we have 2 main well-established head and neck cancer cell lines, the vitro cell lines, as well as the FADU cell lines. These are well-established head and neck cancer cell lines that are commercially available for us. We also created a cell line that overexpresses CXCR4 through a lentivirus transduction. And this is kind of showing here a funny picture of that. But basically, our cells were treated in vitro with 500 nanomolar of log dimer CXCL12 every other day, with and without radiation. And basically, just to kind of give you a little bit of a background regarding the CXCL12 log dimer, CXCL12 exists as a monomer and a dimer conformation in human physiology, but a group of investigators engineered a log dimer conformation, and that was shown to be highly resistant to enzymatic degradation. And as shown here, it's been shown to have a higher anti-proliferative effects than the log monomer. Little sidetrack, my apologies. Anyways, proliferation was also measured using an automated hemocytometer with trypan blue exclusion. And the CXCR4 expression of our cells was evaluated via immunocytochemistry, flow cytometry via FACS sorting, as well as RT-PCR. Another cool thing that we did was we measured apoptotic markers using a pre-custom PCR TaqMan array plate at 3 different time points. This is a PCR pre-custom plate that has a bunch of pro-apoptotic primers, and you can customize it. So our results, well, basically, we see that log dimer CXCL12 demonstrates an anti-proliferative effect across head and neck cancer cell lines. Here, I'm going to draw your attention to this figure 3. We see that with the trypan blue exclusion, in counting our Detroit cells, we see that our control has about 2 million cells at 5 days. And then here, once we induce CXCL12 log dimer into the system, we see there's a massive decrease in cells. Now, if we give radiation to those cells, we see an even greater increase in cell death, which is telling us that whatever's happening is killing the cells. Now, a morphological image here with FODU cell lines, we see here that with radiation therapy alone, there's quite a bit of cells, but now we induce log dimer into the system, we see a decrease in cells morphologically, and now we induce radiation and log dimer, and we see a higher increase or higher decrease in cells morphologically. So this is to say that whatever's happening is killing the cells, and that radiation is acting synergistically with that. Now, we wanted to see if what we were doing was working via the CXCR4 receptor, because if it didn't, then our work would have been not useless, but it wouldn't been as important as what we found. Fortunately, by measuring the CXCR4 expression, both with FACS sorting, with flow cytometry, and with immunocytochemical analysis, we saw that however the CXCL12 log dimer is working via the CXCR4 receptor. So now drawing your attention to these images, which are actually kind of pretty, in my opinion, we see that the blue is a DAPI stain, which is a nuclear stain, the nucleus of the cells. And then the green is a GFP tag CXCR4 antibody, which is showing the expression of CXCR4 in the cell membrane. So now this is our control. And then this one is with log dimer induced into the system. And we see that we no longer see the CXCR4 expression. And our hypothesis is that this is happening because this ligand is binding to the receptor, and then what is happening is receptor-mediated endocytosis. So it's no longer shown to be in the cell membrane, and that the ligand is working via that receptor. Now, we saw that quantification via FACS, and we see, first of all, that both Detroit and FODU cell lines have a pretty high receptor expression of CXCR4. You see about 60 or 70% in those cell lines. And now we induce CXCL12 log dimer into the system, and we see a massive downregulation of the receptor levels, once again proving that whatever is happening via the CXCR4 receptor, and that receptor-mediated endocytosis is happening. Now, lastly, we see here in figure 7 our pretty pro-apoptotic marker TaqMan array plate, and we're using FODU cells here. Everything is normalized to control, and basically we have this data at different time points. This is at day 3 post-treatment. We control log dimer, radiation therapy, and radiation therapy plus log dimer. Everything made normalized to the control, and we see an upward trend of pro-apoptotic markers telling us that there is a lot of death going on with these cells when you induce log dimer, and even a more so increase in cell death when you induce the when you combine radiation therapy with log dimer. Now, these are about, as I said, the 200 to 300 primers for apoptotic markers. But one that we saw that was significantly increased was TNF alpha. So one of the incoming experiments that we have is using a TNF alpha inhibitor to see what the effects are. Now, our conclusions, basically, log dimer downregulates CXCR4 in both flows via both. I'm sorry about that. Log dimer downregulates CXCR4 in both flow cytometry and immunocytochemistry, really suggesting that whatever is happening via this receptor. We also validated the anti-neoplastic importance of CXCR4 by seeing a higher radio-resistant and a higher proliferation with the FODU overexpression of CXCR4 cell line that we created. this cell line was highly radioresistant and very pro-proliferative. The lock monomer CXCL12 or the full antagonist AMD 3100 really didn't demonstrate any anti-proliferative effects or synergy with radiation therapy. This is suggesting a biased agonism of the log dimer of CXCL12. And part of the reason why this is so is, as I mentioned, is that log dimer CXCL12 is highly resistant to enzymatic degradation based on the literature that is out there. And basically summarizing, this is really showing a promising compound that might be potentially used in the future in combination with the current treatments of combating head and neck cancer. Now, what we need to really figure out are the downstream mechanisms, intercellular mechanisms that are happening via the ligand binding to this receptor, and we'll see how everything is working intracellularly. One of the other things that we have currently working on is seeing what happens when you knock the gene out of the system, in vitro at least. And we're doing this via CRISPR. We have done the CRISPR, and now we're just growing the cells. Hopefully the CRISPR works, and we'll see what the effects are, and we'll be able to compare the knockout, an overexpression, and a control of CXCR4. But with that said, I know I exceeded 5 minutes. It takes more than 5 minutes to present this data. But I just want to say thank you to my mentors, to Dr. Joseph Zenga and Dr. Heather Himburg, and thank you for the Center for Immunology for funding this program. I appreciate the support that everyone's been giving me, and I'll be happy to answer any questions in person at the symposium. Thank you very much.